Okay, here's one more example of an exponential application. So in this one, the number of milligrams, D, of a drug that is left in the patient's body X hours after it is taken is given by this equation. So they ask us how much of the drug was there to begin with. And so, of course, that means that we want to plug 0 in for X right after no time has gone by. How much of the drug is there? And that's, of course, going to be that number sitting out there of 200. So we started off with 200 milligrams of the drug. Now I'll ask what percent of the drug was broken down each hour. So remember that we talked about how we can always take our exponential equation and write it so that it has the 1 plus the rate. Now, in the last example, I believe our B was 1.15, and so we turn that into 1 plus 0.15. But in this case, we have 0.9, so we still want the same format, right? We want a 1, but we would have to subtract 0.1 in order to equal 0.9. So this would be another way to write the equation. And once I do, then I can see that 10% of the drug is broken down each hour, right? In other words, it kind of gets rid of 10% of itself each hour. Now, how much of the drug will be in the patient's body after 12 hours? So that's just taking our equation, but putting a 12 in there for X. And I get 56.5 milligrams there. And finally, if we want to graph that relationship, right, our X is the time in hours. And here are the milligrams of the drug. And we can see that we have, okay, we had 200. This answer in part A means that we have 0, 200 as a point. And then this one means we have 12, 56.5 as a point. All right, so in that case, maybe we will let each notch be 10 in the Y values. So we'll say, let's just mark every 50 though. So there's 100, 150, and 200. And then, of course, in the hours, each one can just be 1. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So we know that we're at 12, 56.5. So that's just going to be right about in here. And we're at 0, 200. And I'm going to put that in a different color. And so we know this is a exponential decay. And so what we know from our knowledge of just the general shape of these is that this has to be our general shape. And I didn't do a great job there, so let me try that again. And eventually it is going to work its way down to 0 after a while. And of course it won't dip into negative, but of course that makes sense, that over time the drug should work its way out of the person's system.